Hello, so in this video we're going to take a deeper look into the axis of symmetry and the vertex and how to find these. So we're going to start off with a couple of examples on how to do it graphically, and then we're going to move on to how to do it algebraically, so with numbers. So if I have this parabola and I were to find the axis of symmetry, then, well, the thing you need to know is that because of symmetry, the axis of symmetry is going to be straight between these two roots, the two x-intercepts. So if I have an x-intercept at 1 and at 5, then the middle of those, the average of those two numbers is going to be 3. And therefore the axis of symmetry is going to be x equal to 3. So by symmetry, if I know the two x-intercepts, I can just take the middle of those. That's going to be the axis of symmetry. If I had something like this, where the vertex is actually on the x-axis, well, then this is the vertex, and we know that the axis of symmetry goes through the vertex. So if the vertex is at x equal to 4, then the axis of symmetry is x equal to 4. Right. In general, if I didn't have any numbers, so how would I then find the axis of symmetry and the vertex? So the thing you have seen is that we can find the two x-intercepts using the quadratic formula. And actually, you've also seen that if the vertex is on the x-axis, then I have one solution, which is this negative b over 2a. So it turns out that this negative b over 2a, that's actually the axis of symmetry. And this plus minus the delta thingy, that's actually the symmetry. So from this axis of symmetry, I get this plus minus, which amounts to, from this I could go plus quadratic delta over 2a or minus that. And because of this symmetry, I get, this is the middle, and then these two would be the two x-intercepts. So this thing in the blue box, that's actually the formula for calculating the axis of symmetry. So if I were given a function, how would I then find the vertex? Well, we've just seen that the axis of symmetry was given by this formula, negative b over 2a. And I know that the axis of symmetry always goes through the vertex. So what I would do is I would use this formula to calculate the x value. So for an example, I could have something like this, and then I would calculate this formula, and in this case b is negative 4, so minus b would be positive 4, and a is 1, so 2 times a is going to be 2. And then 4 divided by 2 is just going to be 2. So I know that the vertex is going to have the x-coordinate of 2, because the axis of symmetry is x equals 2. Now what I do is then, I know the x, I just need the y. So I just take this found x value and I substitute it into every x in my function. So instead of x squared minus 4x plus 3, it's going to be 2 squared minus 4 times 2 plus 3. And then I calculate this. So 2 squared is 4, 4 times 2 is 8, and then 4 minus 8 is negative 4, plus 3 is negative 1. And now I know that x was 2, and I just calculated my y value is negative 1, and therefore the vertex is going to have the coordinates 2, negative 1. So to sum up, if I have the graph, I can use the symmetry and say if I do know the two x-intercepts, the axis of symmetry is going to be straight in the middle of those. If I don't have that, if I have an equation, then I can use this formula to find the axis of symmetry, and that's also the x-coordinate of the vertex. And then when I have the x-coordinate, I just substitute it in on x's place and calculate the y-coordinate, and then I have the point I need. That's it. Hi.